Hey, what's up YouTube? Today we're going to be talking about differentiability. So this is a very simple topic and should be pretty easy to cover, so let's get right into it. First, before we get into whether parts of a graph are differentiable or not, we should determine whether they're continuous or not and kind of just review that, because here's the first rule of differentiability. If it's not continuous, then it's not differentiable. By that I mean, you can't find the derivative at a point on the graph where it's not continuous. Remember that the conditions for having a continuous function is that the limit exists and that the limit at that point is equal to whatever the value is at that point. For example, let's use this in blue. At this point over here, the limit exists because when you approach it from the left and when you approach it from the right, it approaches this number over here. And the number when you plug it in is exactly the same. As a rule of thumb, you can move your pencil along it and you don't have to pick it up. Now, remember that there were 3 times when you would have a non-continuous function, and those would be those 3 over here that I'm going to put in a box, because these are the conditions for where it is both non-differentiable and non-continuous. So the first one is a jump, and that's this one over here, just to review. Basically, the limit does not exist, because when you approach it from the right, you approach this number. When you approach it from the left, it's this number. The second is removable discontinuity. This is when the limit exists, but the point here either is not the same or just does not exist. So either this point could be here or it could not be here. Actually, this would be removable discontinuity. It would be non-removable, I believe, if it wasn't here. Anyway. The third condition was that infinite discontinuity, where it approaches upward and downward infinitely. So obviously, this is not continuous. Now, the last 3 are where the limit does exist, and the point does exist. It's continuous, right? However, you have to remember that the slope, remember, the limit is trying to find, for derivative is when you're trying to find a slope, is not the same. So, let's just take, for example, the first one. This one will be a corner. The slope at this point, so I tried to make this as straight as possible, looks something like this, right? So it's a negative slope. However, when you approach this point over here, the slope is like this. So, when you approach this corner point here, the slopes are not the same. So for a corner, it's non-differentiable. An example of this would be just an absolute value function. F of x equals the absolute value of x. What you have is just a corner, so the slope over here would be like -1, and the slope here would be 1, and therefore the slopes are different as they approach this point, so we don't know what the derivative or the slope is at this specific point here. Next one is called a vertical tangent. I misspelled it. This usually happens with the circle, so I tried to draw it over here where the slope, the tangent line along this point is just a straight line. So at that point, that would be like having a 1 over 0. Basically, any number over 0, you would get some sort of vertical line, and the slope over here is undefined because of this 0 in the denominator. So an example of this would be just any circle. So if I do a circle over here, the circle would have a tangent line at this point that is a straight line, and therefore the slope would be undefined. Now, the last one is called a cusp. And the cusp usually occurs with something like x to the 3 over 2. And basically, what that means is that when you have this sort of cusp over here, the slope at this point approaches infinity like this, but then when it comes out like this. So the slope over here is negative. It's getting more and more negative. But on this side, it's getting more and more positive. So as you can see, when it approaches this center point, we really can't tell what the slope would be at the point over here. And that's basically it for differentiability. There's one more point that you need to know for your AP tests, if that's what you're coming here to study for. It's that the endpoints are never differentiable on a graph. So for example, if we said that this was endpoint B and this was A, you would say that they're continuous on A through B, because it is continuous. Now, let's just imagine that it was differentiable. Let's imagine that the graph just looked like this. Now, at this endpoint over here, B, let's pretend it ended over here, right, B, you would say that it is differentiable on A through B, but not including A or B, because remember, for it to be differentiable, you need to have a slope coming in from the right. But if the endpoints are right there, there is no other line over here extending outward, so there is no slope coming inward. Therefore, the endpoints cannot be included. They're not included as points that are differentiable. I hope you enjoyed the video. I hope you join me tomorrow when we cover more math, and thank you for watching.